Okay, lesson 12.6. Here we go again. Your friend offers to play the following game with you. If the product of the roll of 2 number cubes is 10 or less, I win. If not, you win. Okay, so this is the game. The first question we're going to answer about this is, if you were to play the game many times, what percent of the games would you expect to win? So basically, what's the probability that you would win this game?
Not very high.
Okay, so what do we need to know in order to figure this out? Okay, we need to start by looking at, it mentions the product of 2 number cubes, yes? Now, does this chart look familiar? We handwrote this chart earlier on in chapter 12 somewhere, didn't we? In order to answer some questions. I was nice. I found a piece and copied it in for you so we don't have to handwrite it out again. So with the idea that along the side, or one of the sides, this is your first die being rolled, and then along the other side is your second die being rolled, right? And they want to know, we're talking about probability of a product in relation to 10, right? So what do we probably need to do with all these? Probably be helpful to find their products. My recommendation, what I did is I went in and wrote in the products next to each of them so I could just visibly see, and I don't have to sit there because they're not really in like an order necessarily to where, like, you know, the sums are nice, neat, you can look at the diagonals. These you can't really. So if we start writing in the products, 1 times 1 is 1. If I go down the column, 2 times 1, 3 times 1, 4 times 1, 5 times 1, and 6 times 1. Okay? Just keep going. The next column, 1 times 2 is 2. 2 times 2, 3 times 2, 4 times 2, 5 times 2, and 6 times 2. So you've got all your multiples of 2, yes? 2, 4, 6, 8, 10, 12. Next column, 1 times 3 is 3. 2 times 3, 6, 9, 12, 15, 18. All of your multiples of 3, yes? Next column is going to be your multiples of 4 if you haven't figured out this pattern here. 4, 8, 12, 16, 20, and 24. Multiples of 5, 5, 10, 15, 20, 25, and 30. And multiples of 6. 6, 12, 18, 24, 30, and 36. Okay? Again, maybe it's just me, but I find it helpful to have all those written out. Okay, so we need to figure out percents of winning here. So what is a win? So we want to know the probability of getting a product of 10 or less. Yes, I should have said product on there, but I didn't. So what are your thoughts on a product of 10 or less? Is that right? Dang it. I've totally miscounted. 6. Okay, should be 19, yes? Sorry, I had a moment of... And that's 19 out of, did you guys say it?
36.
36, because there's 36 different pairs. Okay. Now, if the probability of getting 10 or less is 19 out of 36, what's the opposite of that? Yeah, and that would be the probability of getting, what do I want to say, instead of 10 or less, more than 10. That works too. So probability of more than 10 is 17 out of 36, because those are your 11s and 12s pretty much. Oh wait, we're not just adding. 11s up to 36s, there we go. Now, it says if you were to play the game many times, what percent of the games would you expect to win? This is a tricky question, because you have to read and understand the problem. Which one is you?
19 out of 36.
Yeah.
Yeah.
Because you want 10 or less to win.
Wait.
No, it's
no,
17
it's the
out of
opposite.
36.
You're the 17 out of 36
You
because it says
win if it's.
Yeah.
Okay, so your friend offers to play the following game. Your friend offers to play the following game, quote, if the product of the roll of two number cubes is 10 or less, I win. Who's I in that statement?
Then you person
That is the friend.
enemy friend.
Jonathan's harsh here. Okay, so that's the friend, and then if not, you win. So who? So that is the 17 out of 36, yes? Be careful reading on these. You really have to stop and think, which point of view is this from? Now, the question was, what percent of the games would you expect to win? So what's that going to be? 17 out of 36. What is that as a percent?
4, 7, 2, 2, 2, 2.
Okay. Yeah. As a decimal, it's 47.2 repeating, which as a percent then becomes 47.2% or 47%, whatever form of that you use. Okay. B. Is the game fair?
No.
Should you take this offer and play this game with your friend?
Oh, no.
Do you have a good chance of winning?
Yeah.
It's close, but if probability holds true, you're guaranteed to lose, aren't you? I mean, I get it, it's close, but here's the deal. If it is what we are officially calling a fair game, it's equal probability. You have an equal chance of winning versus an equal chance of losing. The way this is right now, I have a 47.2 chance of winning, which means I actually technically have a greater chance of losing at, what, 52.8? Okay. So, for that matter, is the game fair? No. Should you take the offer? No. And my reasoning is because you only have 17 ways to win. Your friend has 19. Okay. And C, suggest a way to change the game from fair to unfair or vice versa while still using the product of two number cubes. Now, we've already decided this is not fair. So this question is written with the idea of they're not trying to tell you what the previous answer was. But suggest a way to change this game from not fair to fair, or unfair to fair, but still using the product of two number cubes. So basically, how can I change the rules, change the directions, but still use product of two number cubes?
If it's even, so it's even I will.
And I don't know on that one. Does even and odds work? I'm not sure if it does.
Well, let's see.
And that's where you'd have to count.
3. No, even 2. Yes, that would work.
You think we have equal, even, and odds? I don't.
No, there's weird.
I think there's more evens than there are odds. Just because I see here a column of evens, and I see a column of evens here.
Oh, God, I was lost.
27 evens.
Okay, there we go. 27 evens, definitely not fair then. Okay. Now, here's the deal. If we were talking sums, we could go for that rule. Okay, because if we were talking sums, it would be 50 and 50, I think. But
12 or less.
12 or less is going to give me even a bigger number than 19 out of 36.
Yeah, I think that shot is up to you.
8 or less. I don't know. 9 or less.
Definitely.
Would it be less than 10?
So what happens if we do less than 10?
Because there's only 2 10s on the chart. That makes it.
There are 2 10s on the chart.
Wouldn't that just flip?
Yeah,
So-
flip it at that point.
Okay. So there's an option here, and I just noticed because of the option the book gives, but morning class also came up with this option. There's an option where you can kind of tweak this a little bit. Still centering around 10, but kind of tweak it.
Just not play.
That's a good one.
Not the option I'm looking for.
There's 100% chance.
10 or less or 10 or more, but I get a 10, you get a 10.
As you can read here in the original
Okay.
contract, your friend offers to play, not forces, offers, thus meaning you can decline the said
Okay.
offer.
How about if we go,
Wait, you still have to use all 6, or can you make it 5?
these are 6-sided dice.
Just kidding.
Okay. Okay, how about the idea of a less than 10 and a more than 10? And then what about 10s?
No change.
You re-roll.
We hate tens.
10, no one gets a point for 10s. Or no one wins for 10s. Does that make sense?
So we just kind of cut it out.
Okay. Well, it's just, everything else, less than 10, the friend wins.
Yeah, and I make it 50.
More than 10, I win. Or you win. And then the 10s, if there's a 10 roll, you just re-roll. Okay. Kind of the same idea Autumn said. I get a 10, you get a 10, whatever. It's a tie, whatever. But, in other words, it's not a win or a loss for anybody, basically. Okay. So, I'm going to just kind of shortchange this, that we can change this. Let's see, how is it up here? 10 or less. So we can make one group less than 10. We can make another group more than 10. And 10 is a reroll. You just re-roll the dice and try again. That's very much shorthand because I don't want to write out a whole big paragraph, and I don't think you guys care if I write out a whole big paragraph, so you just assume I not, right?
What if a friend offers to do this?
Friend that likes to win
Yeah, but like.
and is hoping their friend is a sucker and won't play the game.
Well, but what are the odds that actually,
Yeah,
fun?
probability against what actually happens
Who
is
knows?
different. And
Who
adding,
knows?
and adding on to that, there's much better ways to scam your friends. Not that I would know, but there are much better ways. That make
I
them
hope you don't
seem
have
like
any
they're
friends
winning.
sitting in here that you're giving your secrets to.
No comment.
Instead.
Okay, guys,
Never take advantage.
moving on. Okay.
But you still owe me some money.
Talking probability here again. Using probability to make fair decisions. Sadie, Tamira, River, Victor, and Jay are candidates to represent their school at an event. How can you use random integers to select 2 students from the 5 candidates so that each one is equally likely to be selected? Okay.
I have a river in my classroom. She's Myers. Mrs. Myers' daughter.
What'd you say?
Mrs. Myers' daughter named River. She's in my first grade.
Oh, River? I had a River graduate several years ago, River Dalton. The Daltons that run Team Blast, one of their daughters is River. So, random. Okay, so back to this. Assign everybody a number, right? Assign everybody a number, 1, 2, 3, 4, 5, and then you need a way to pick that number, right? Very non-technological, but it works. Put them in a hat, right? Okay. Now, are you guys familiar with random number generators?
Yes.
Like,
I'm good.
Like the one online?
Like the one on your calculator.
No.
Okay, we have one on here.
Yeah.
Well, I want an RNG generator.
You have one.
We call it RNG. It's a gaming term.
So any scientific or graphing calculator is going to have one somewhere. Now, I can't necessarily tell you where in all of these, but on our scientific, so it's going to be in with your probability stuff, and you're looking for RAND, R-A-N-D. And actually what I'm going to use is RAND-I, which is RAND integers. So for me, I go into my probability button. Now, probability, this is where we have the NPR, NCR, and the exclamation mark. I'm going to arrow to the right. And if I arrow to the right, I get RAND and RAND-I. Now, I'm going to use RAND-I because I only want integers. If I use RAND, I'm going to get decimals thrown in. I only want the numbers to be picked to be 1, 2, 3, 4, or 5. I don't want 1.238 to be picked, right?
Like the long decimals?
Right.
Or short
They're long decimals.
Oh.
Yeah. So I'm going to go over to RAND-I, and yours might be RAND-int, like INT, whatever. I'm going to hit enter. Notice it's RAND-I. Now, in my parentheses, I'm going to say what my range of numbers I want to be. So I want a number from 1 to 5. I used a comma earlier. I'm not sure if you could use like a hyphen between them or not, but I'm going to do 1. The comma, if you're not familiar, is right here above the right parenthesis. So second parenthesis, 5. So when I hit this, it's going to randomly generate a number between 1 and 5. And I can continually hit enter. 5, 4, 2, 1, 2, 3, 4, 5, 5, 5, 5, 1, 1, 2, 3.
My calculator is biased towards 2.
My calculator is liking to be repetitive. I haven't seen any 2s or 4s on mine. There's none. But there is a way to do that on your calculator. It's in the probability section. It's called RAND, RAND-INT, RAND-I. It varies from calculator to calculator. Okay, but now, are there random number generators online too, that type of stuff? I'm sure there are. Okay, but that's the option, that's a suggestion here. Drawing a number from a hat, the much more basic version, right? Does it work? It works, okay? So, what I'm going to say here, I'm going to say assign each candidate a number 1 through 5, and then use a random number generator to generate random numbers. Use a random number generator to generate numbers. Now, I can honestly say I don't exactly remember how to do it, but there are ways on the calculators where you can say, okay, I want numbers from 1 through 5, and I want you to give me 2 numbers at a time, things like that. So you can get fancier with these random number generators. This was very basic. You can get very fancy with them too. So, okay. Next one. Your trainer creates training programs for you. How can you use index cards to randomly choose the following? Strength training 1 day per week, cardio training 2 days per week, with no consecutive days, and swimming 1 day per week.
I have an idea.
Okay, what's your
Put it in a
idea?
hat.
Put what in a hat?
The index cards.
What's on the index cards?
The training days.
The what?
The training days.
As in, what do you?
Strength, cardio, swimming.
So like you say Monday and then you pick out one.
Yeah.
And that's gonna be Monday.
How are you picking which days you want to use?
Get yourself another hat. Every week. 2 hats. Boom, boom. Mondays we're doing cardio.
That is very smart.
Tuesday.
So picking an index card from one hat that has, say, cardio on it, and then an index card from the other hat that has a day of the week. Okay.
Right. Works.
The only point I'm going to make is I think your days of the week have to be on the card someplace, somehow. Okay. Now, the way I had this, and again, there's not just one right answer on these situations. You guys get that, right? Okay. I was just going with each day of the week on a card, and then, you go to draw, okay, this card I'm drawing is for strength. There's my strength day. Then you draw a card for cardio. And then you draw another card for cardio, right? Now, if you happen to get 2 back-to-back days for cardio, put it back and redraw. Okay? Now, adding more interest to it, though, pick 2 random cards, yes? As again, there's variations on this. Okay, so you write down something for you. As I said, I definitely think days of the week need to be on the cards, so you can pick them from a hat, that's fine.
2 backs, actually.
So I was going to put days of the week on index cards, randomly select cards. Randomly select cards for training, for trainings. If cardio gets back-to-back days, select again. Again, lots of tweaks and variations on that, right? So if I were to put something like this on a test where you have to come up with something like this, then it's just going to be, I'm going to need something that legitimately works, okay, that makes sense, and, go from there. So not just one right answer. Okay. As we turn to the next page, determining whether a decision is unfair or fair. We talked about that a little bit up there with the very beginning today and the product of 10 on a dice. Here we're going to talk about, if you remember, expected value. We're going to use expected value to help us decide if something is fair or unfair. Thado places 3 cards in a hat, labeled 1, 2, and 3, and challenges Helena to a game. So here's the hat that you are so wanting. Thado says, if you draw a number greater than 2, you earn 2 points. Otherwise, I earn 2 points. Is the game fair or unfair? And if it is unfair, which player has the advantage?
Unfair? That's just plainly obvious. Like you would just watch it.
It's unfair.
Yeah.
That has the advantage because if Helena only gets 2 points if she gets 3.
Yeah,
And he gets 2 points for 1 from the 2.
And I bet that it's a casino too.
Okay, so when we talk about drawing a number greater than 2, what are the numbers greater than 2? 3. Whereas Otherwise, he earns 2 points. What are the other numbers he could pick?
1, 2.
Or that could be picked. So he's going to win if he gets a 1 or a 2, yes? Whereas she wins if she gets a 3. So thus, now, how do we show that? How do we use expected value to back ourselves up? And that's what we're going to look at here.
She has a 33% chance.
Right.
He has a 66% chance.
Okay? Now, okay, that's exactly what we need to talk about. So, let's see. If Helena wins, she's going to get 2 points, yes? Oh, wait, actually, we're going to look at this from Thado's point. Yeah. If Thado wins, he's going to get 2 points, right? And what are the chances that he wins? What's the probability that he wins?
2 out of 3.
2/3, because he's going to win with a 1 or a 2 draw. Should have done this the other way around. Now, we're thinking about this in terms of Thado, yes? If he wins, he gets 2 points. If Helena wins, we're going to call that negative 2 points, because that's 2 points that he doesn't get, right? They go against him. And so that right there is representing Helena. What are the chances of Thado having 2 points against him? Or in other words, Helena winning? That's 1/3, because that is only the 3, yes? So essentially, this is if Helena wins, and this is if Thado wins. Now, do you remember expected value? With expected value, we did the outcome times the probability. And we added those up, right? Outcome times the probability. Outcome times the probability. So in this case, Thado's outcome is a 2 times the probability of him winning, which is 2/3. Plus, Helena's outcome, in reference to Thado, is a negative 2 times her probability of 1/3. Okay, well, let's do some math. What is 2 times 2/3? 2/1 times 2/3 is 4/3. Plus, what's negative 2 times 1/3? It's negative 2/1 times 1/3, so negative 2/3. What is 4/3 plus negative 2/3? 2/3. Okay. Now, so what's that 2/3? That is showing that the chance of the advantage is going to Thado, yes? Okay, and here's the deal. The comment is down here. If a game is fair, you're going to have an expected value of 0. Because that expected value of 0 is going to represent one way is not more likely to win than the other way. Here, since that's 2/3, that's going to be the probability. That's, it's your expected value, but that's going to be showing that Thado is 2/3 more likely to win. Okay, so is the game fair or unfair? Unfair. And if unfair, which player has the advantage? And that advantage goes to the Thado. We've had some interesting names this week, haven't we? FYI, I don't make these names up. I take these problems from our book. Just saying. Okay? These are not me getting creative with names. I'm not that creative. Okay, B. Let's change it up. Helena proposes a change to the scoring of the game. She says, if I draw a number greater than 2, I get, and this is supposed to say 2 points. Otherwise, you get 1 point. Is this game fair or unfair? If it is unfair, which player has the advantage?
I'd say it's fair.
Wait,
Can we figure this out?
It says I get points, not a specific number of points.
And I just told you it's supposed to say 2.
oh, okay, sorry.
But it doesn't, though.
Turn up your hearing aids.
I don't have, nor do I need to meet.
You need Felix's career.
That is the second time I've heard that come from you.
Okay, now, focus, guys. Focus. So, with this, we're changing it up. What's Thado get this time when he wins? So this time, probability of Thado winning, he's going to get 1 point. What are his chances of winning? It's still 2 out of 3, yes? Because it's still, if I draw a number greater than 2, which the only number greater than 2 is 3, she gets 2 points. Otherwise, you get 1 point. So you get 1 point for getting a 1 or 2, right? So that is still 2 out of 3. What's the other option? If Helena wins, she gets 2, which is 2 points against Thado, right? So that's probability of negative 2. What's the probability that she wins? And that's 1/3, because she can only win with a 3. Do the expected value now. This time we're going to be doing 1 times 2/3 plus negative 2 times 1/3. Well, 1 times 2/3 is going to be 2/3. Negative 2 times 1/3? Negative 2/3. What's 2/3 plus negative 2/3? 0. What is that telling me then? This game is fair. I think you guys kind of already logically figured that out. But this is our method of what we can use to figure out for sure if it is fair. So I'm going to say fair, and the reason it's fair is because the expected value is equal to 0. Okay? And we will stop there. Okay. Get 12-5 finished up, guys.